Hi there, it's Mrs. Ortiz here, and this is Objective 4 for the linear unit in Algebra 2, and we are focusing on writing linear equations today. So the question that we are being asked is, how do we write linear equations, okay? And so really the key to that is going to be using a slope-intercept form, so just like we used to graph equations, we're going to write linear equations. And the two parts that we need to replace with numbers are the slope and the y-intercept. Okay, so hopefully that's familiar to you from the previous video and from Algebra 1. Okay, so quick review. These questions asked us to find the slope, so a quick review of what slope is. So slope is the rise over the run. It is the change in y over the change in x. It is the equation, the formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then slope, something that I forgot in the Objective 2 video, is that slope is also the rate of change. So how quickly something is increasing or decreasing. So the rate of change. Okay, so all of those ideas are what slope represents. So in this first example, it says find the slope of a skateboard ramp, excuse me, that has a rise of 15 inches and a run of 54 inches. So we can use the rise over run to answer this question. And we know if that slope is equal to the rise over the run. So if it has a rise of 15 inches and a run of 54 inches, the slope is 15 over 54. And we do need to go ahead and simplify that. So we can divide both of those, the numerator and the denominator, by 3. And we get 5 over 18 for our slope ratio. Okay. In the second example, it asks for us to find the slope of a line that passes through the point -1, 3, and 2, -1. So for this one, we're going to use the formula. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we're going to substitute our values in. So if this is going to be the first point, we'll call this x sub 1, y sub 1, and this is the second point, x sub 2, y sub 2. So to substitute those numbers in, we're going to do -1 minus 3 over x sub 2 is 2 minus -1. And that's equal to -4 over -2 minus 1 is a +1, 3. So our slope here is a -4/3. Okay, so a couple examples about finding slope and reminding ourselves what slope is. All right, so when it comes to actually writing the equation of a line, I'm down here now, okay? We are going to find the slope, then find the y-intercept. So remember that the slope is m. And we're going to find the y-intercept. I want a pen, not a highlighter. So m. Find the y-intercept, which is b, and write the equation in slope-intercept form. Y equals mx plus b, okay? If we go back up here, there are some ideas about how to find slope. So use the rise over the run on the graph. You could use the change in y over the change of x in a table. Maybe you have a rate of change, or you can use the formula for slope if you're given 2 points. To find the y-intercept, if you don't have the y-intercept, you're going to use the equation y equals mx plus b, and you're going to substitute in for y and m and x to be able to solve for b, okay? And you get the x and y from one of the points that's given. All right, so let's try a few of these. So in number 3, it says, well, the directions say write the equation of a linear relationship using the given information. In number 3, our slope is 2/3 and our y-intercept is 0, -4. So we need to, in order to write the equation, we need y equals mx plus b, and we need to identify m, which is 2/3, and then the y-intercept, which is where x is equal to 0. So this is 0, and this is going to be b. And so b is equal to 4. And we're just going to substitute those in. So y is equal to 2/3 goes in for m, x plus 4. And there's the equation of our line. When it comes to number 4, I would like you to do that one on your own. But maybe you want to watch number 5 first to know how to do it. So in number 5, we have a line that passes through the points 1, 6, and 4, 27. So again, we need y equals mx plus b, and we're trying to find the slope and the y-intercept. So m and b. So for m, we've got these 2 points, 1, 6, and 4, 27. And so for this case, we're going to use the equation to solve for our slope. So our change in y, so 27 minus 6, over our change in x. Now, if I started with 27 first, I have to do 4 first. That's very important that you keep the order the same. So then 4 minus 1. 27 minus 6 is 21, 4 minus 1 is 3, and our slope reduces to 7, okay? So now to solve for b, okay, I don't have b, but I do have a y, and I do have an m, and I do have an x. So I'm going to use this first point 1, 6, and I'm going to substitute in an x and a y, and I'm going to substitute in 7 for m. Okay, so for y, because y equals, we're going to start with 6, the y coordinate of that point is equal to, and then I'm going to do the m is 7 times x. Well, what was the x coordinate when y was equal to 6? It is 1, so we're going to substitute in that 1, plus b, and now we're trying to solve for this b. So 7 times 1 is 7, and that's equal to 6 plus b, and then we need to subtract 7 from both sides. So b is equal to, let's see here, I'm going to rewrite this, 6 equals 7 plus b. Subtract 7 from both sides, 6 minus 7 is -1, and b is equal to -1. Okay, so now we substitute in -1 for b and 7 for m, and our equation is y equals m, 7, x plus b, which was -1. And we should really simplify that plus -1 to just a -1. Okay, so writing the equation of a line given 2 points. So if you need to go back and do number 4 now, the process for solving for b will be the same in number 5 as it is for number 4. Okay, in number 6, we're still writing the equation of a line. This one it's in the context of a problem. So a computer costs $750 and it depreciates $100 every year. So for this particular one, we need to think, again, we still want y equals mx plus b. So we need to think about what is m in the context of a problem and what is b in the context of a problem. So remember at the beginning of these notes that I said that m is the rate of change. So how quickly something is changing. And then if you go back to the section 2 notes, when we talked about b in a little bit more depth, we said that this was a starting point, okay? And so in the case of a computer, it's the starting value. So if y is equal to mx plus b, okay? So our rate of change and our starting point. Let's start with the starting point. The computer started at a value of $750, okay? So that's b. And then it depreciates $100 every year. So our slope is $100, except depreciate means that's losing value. So our value is going to go down and it needs to be a -$100. So we're going to substitute in those values for m and b, and y is equal to -100x plus 750. And there's a model for the depreciation of a computer, the cost of a computer after x years. All right, so that is number 6. Number 7, the example for number 7 is in a table form. So let's go back to, remember we want y is equal to mx plus b, okay? And we want to replace m and we want to replace b. So remember that we'll start with the easy one, which is B. B is the starting point. It's also, so the y-intercept, where x is equal to 0, okay, and then the y-coordinate is B. So if we look at our table, x is equal to 0 right here, which means that when we put in 0, we get out 12,000. Okay, and this is the value of something, maybe a car or I don't know. I don't know if you can buy a car for $12,000 anymore, but all right. So when x is equal to 0, y is equal to 12,000. So that is our y-intercept. Okay, so B is equal to 12,000. Now, M, let's switch colors here. So M is rise over run, or the equation for slope, or the rate of change, and it's also the change in y over the change in x. So when we have a table that's going up, when our x values are going up by, well, they can be going up by anything, but they're going up consistently by 1, we can look for the change in y over the change in x. So what I want to know is, how is my y changing? So to go from 12,000 down to 10,750, what is my change in y? Okay, so my change in y, so what is the difference between 12,000 and 10,750? And it looks to be, we're decreasing, so that's going to make it negative 1250 each time. And we should just check that this is consistent. So is 950 down to 8250 or decreased by 1250? And does 8250 reduce by 1250 to get to 7,000? So it looks to be consistent, which is good. So we want to know what the change in y is, and if we use these 2 points, we're going to use those 2 points again to find the change in x. So the change in x is going from 0 to 1. So it's changing by a positive 1. So as the year increases, the value goes down by 1250. So if slope is change in y over change in x, then we're just going to substitute in our 1250 for our change in y and our 1 for our change in x. And now we have m and b, and we can write our equation. Y equals m, negative 1250, x plus b, which is 12,000. All right, so that is the equation for number 7. Okay, so for number 8, I'm going to have you do number 8, but I just want to talk about the idea of a line of best fit for a minute. So the line of best fit is the line that fits a set of data points. So all these data points were collected. These are basketball stats for somebody. So based off of the number of minutes of played, how many points did they score? Thankfully, it's increasing, so that's good. But what you're going to do for a line of best fit is you're going to have all these points, and then a line is going to be drawn through the middle of the points. And then you're going to look for 2 points, like the 2 points that are the most clear, and write an equation using those 2 points. So if we zoom in on this graph a little bit, okay, we're looking for points that are pretty close to going through an actual coordinate. So I'm going to choose this point, and I'm going to choose this point right here. And I'm going to use those 2 points. So 1612 is the first coordinate. So 16 minutes played, 12 points scored. And I'm going to use the coordinate 2820. And what I would like you to do now is go ahead and write an equation for that line using those 2 coordinates. And remember that we did an example just like this. I think it was number 5. Yeah, number 5. So you can go back to number 5 if you need a reference for doing this one, okay? All right, so to answer our essential question, how do we write linear equations? So the 2 parts that we need to substitute in are the slope and the y-intercept. So we're going to find the slope which we call m, and the y-intercept, which we call b, and substitute them into sorry, Cooper's sitting here with me and he's all right, so substitute the values into y equals mx plus b. All right, now to reflect on your learning, what I would like to know is looking back at the types of examples in 1 through 8, which one do you need more practice on? Okay, and once you answer that question, you are set for today. Okay, have a great day. Bye.